Okay. Now, okay. Now let's start. Okay, I don't know what happened to other people, but still we have to start. Raise your hand if you're in the meeting, Putha. Okay. So in the meeting, please raise your hand. Others are not in the meeting. Okay, now listen. Now this lesson today we are going to do. Okay, put your hands down. Okay. Today we are going to do the starting part of inorganic. So I told you inorganic. We got. Okay, we got. It means 22.5 marks out of 100. 22.5 means more than 1/5. Like 22.5% mean for one lesson. It's a very big amount, right? Just only from this unit 6. Therefore, today I will teach you in an easy way. Actually, this is from our practice. Actually, this is from our practice. Okay, so I will share a document. From this, I will explain. After that, I will give you this document to you. There are some adjustments to be made in this, right? So this is the inorganic chemistry note I have prepared. So carefully see this. Again, we have to practice now itself from the beginning. Again, these completely reactions. These completely reactions. Don't get scared. I will teach you. Again, don't try. Don't be in a hurry. Right? Don't be in a hurry. Right? We'll practice one by one. Right? Okay. Now, carefully listen. I will tell you the pattern how to study. But first of all, now we are going to speak about inorganic chemistry. Under inorganic chemistry, right? Under inorganic chemistry, the first part is we are going to speak about S block. S block mean the group 1 and group 2. Right? So group 1 and group 2. In group 1, we got lithium, sodium, potassium, rubidium, and cesium. In group 2, we have beryllium, magnesium, calcium, strontium, and barium. These are the elements we are going to speak about. Right? So very simple. These things are very simple. Right? Is this size to level. Right. Okay. Now, okay. So remember all the elements in group 1 and group 2 are metals. That is the first one. Okay, all are metals. Whatever we are going to speak, everything, those are metals. Now, this is about the properties down the group. Eka will speak bit later. Right? But I have to speak about, first of all, I'll tell about group 1 elements normally. But when you take group 1 elements, normally all are like soft elements, like all are soft metals. Normally the softness, it'll increase down the group. So for an example, if you take lithium, sodium is softer than lithium. When you take potassium, potassium is softer than sodium. So if they becoming softer, what might be happening for their metallic strength? These are metals. What might be happening for their metallic strength? Is it increasing or decreasing? Yeah. Satutika, what do you think? Metallic strength is increasing or decreasing?
Decrease.
Very good. It's decreasing. Excellent. Why? Because it becoming soft means the metallic strength is decreasing. Okay. So when you're going down the group, already you know the radius of the element increases. Yeah, more than lithium, sodium is big. Because when the number of shells will increase when you're going down the group, therefore size increases. Therefore, that's why they have said when you're going down the group, metallic strength will reduce. Oxidation means the ability to release electrons. Right? The ability to release electrons. When the size become large, they can easily release electrons because they are away from the nucleus. Therefore, easily they can release electrons. Then the next one is reactivity. If they can easily release electrons, means their reactivity increases. Then metallic quality, again metallic character Actually, it decreases. Huh? Metallic quality not increases. Actually, it's supposed to be decreasing, right? It should come down. Okay, or something like this. Okay. Right. It should decrease. Metallic quality will decrease. Even here, it should decrease. Metallic quality or metallic nature. Okay, metallic nature. Sorry. Metallic quality increases. Again, metallic strength decreases, metallic quality increases. Again, the ability to release the electrons increases, no, therefore metallic quality or the metallic nature increases. Correct. Other thing is the ionization energy. Ionization energy we'll see later. Ionization energy mean the energy needed to remove an electron. Normally, when the size become large, okay, now let's imagine now there is an element like this. There is a nucleus like this. Now, this is the first atom. This is the nucleus, right? And the other one is large like this. Now, electron is here. Now, which electron is easy to remove? A's electron or B's electron? Someone reply, A's electron or B's electron? Imla, can you tell, Putavi? Yeah, B's electron is easy. Imla, can you tell why B is easy?
Because it's away from the nucleus.
Very good, because it's away from the nucleus. Excellent, right? Because it is away from the nucleus, it is easy to remove. Again, whatever the energy needed to remove this electron is less. Okay, because if I want to remove this electron, I have to give a energy, right? To remove this electron. Okay, so whatever the energy needed to remove this electron is less than removing this. Okay, nice. That's why they have said ionization energy decreases when you're going down the group because radius increases. Melting point, boiling point also will reduces because metallic strength reduces. When the metallic strength reduces, melting point and boiling point reduces. That is okay. Then electronegativity, when you're going down the group reduces, fluorine is the highest electronegativity element, then chlorine is less than that. Okay, likewise, when you're going down the group, normally everywhere in the periodic table, electronegativity decreases. Electronegativity decreases mean electropositivity increases. Electropositivity means the ability to make a positive ion. Okay, the electronegativity decreases mean electropositivity increases. Lustrous mean what do you say? Lustrous mean like shining. Okay, normally when you're going down the group, shiningness increases. Right? Density, normally when you're going down the group, okay, for group 1, density reduces, for group 2, density increases. The thing is there. These are not, don't much bother, don't go to by heart these stuffs. They will no need to by heart, understand how it works. Right. Now, Putha, mainly here we are going to speak about the reactions. Mainly we are going to speak about the reactions. Right. Mainly we are going to speak about the reactions. Right. So in these reactions, we are going to speak based on few things. Based on few things. First thing, you can see the reaction between, first we are going to speak about the oxygen's reaction. Carefully listen. S block elements with oxygen. And S block element, group 1 and group 2 elements with oxygen. Now we are going to speak about that. So when group 1 element, when they react with oxygen, Putha, you can see lithium and oxygen will produce lithium oxide. Sodium and oxygen will produce sodium oxide. Don't see these things. You just keep it. Sodium oxide, potassium oxygen, potassium oxide, rubidium and oxygen, rubidium oxide, cesium and oxygen, cesium oxide. You know to write this, right? Why we have written Li2? Because from O level, lithium's valency and oxygen's valency, when you put oxygen's valency here, this side 2, lithium valency 1. That's why we write as Li2. Now you should know to write these things. You know to write like this. No? That's why we have written. But remember, Buddha, normally group 1 elements, they are highly reactive with oxygen. Therefore, lithium will stop in oxide. Okay, lithium will stop in oxide. But the other people mean, now what will happen with the other people? For an example like this now. Okay? Now, oxygen after reacting with sodium, after reacting with group 1 people, after making the oxide, this oxygen will come and ask from this oxide, shall we react more? Like, shall we react more? Then sodium will reply, okay. Lithium will say, I can't much. But sodium will say, oh, okay, we'll react. Sodium will say. Then sodium will react further and it will form sodium peroxide. Sodium oxide will go to sodium peroxide. That's why it becomes Na2O2. But can you remember something called hydrogen peroxide? H2O2. Same way, this is Na2O2. Right? Then after making Na2O2, even oxygen will come and ask from that, from sodium peroxide, shall we react more here? At that time, sodium peroxide will say, no, I'm lazy after this. I don't have an urge to react with you. So enough here, sodium peroxide will reply. But when you come for potassium, now potassium and oxygen will become potassium oxide. So potassium oxide, when oxygen comes and asks, shall we further react? They will say, okay, and they will make up to potassium peroxide. And after making potassium peroxide, they will ask again from potassium peroxide, shall we react further? Then still potassium is very active person. So he say, okay, no problem, I'm okay. Then they will go up to potassium superoxide. This KO2 means superoxide. Right? This KO2 means superoxide. Potassium, rubidium, cesium, all three people will react up to they make the superoxide level. Lithium will only make up to oxide, sodium will go up to peroxide, potassium, rubidium, cesium will go up to superoxide. Now, you have to remember this, Putha. Right now, just imagine everything with one example. Just take the potassium as the key example. So, potassium oxide is K2O. Potassium peroxide is K2O2. Okay. Potassium superoxide is KO2. Now, carefully listen. Now, you should be able to write the anions of this. See the anions of this. See the anions. And you should be able to write these anions. Now, potassium oxide means what is this anion? This oxygen is the anion. Oxygen. Here, valence is 2. So, you can write as here anion is O2 minus. That is the anion here. Here you can see here O2 is here. This valence is 2. Then how will you write the anion? You have to write this anion as O2 2 minus. Carefully listen this. O2 2 minus means peroxide. Now this is just oxide. Okay, this is just oxide. This one is just oxide. This one is peroxide. That only we are saying as peroxide. This is peroxide. And this one is known as, how will you write this? O, can you say this? O2, this
Minus.
one, if there's nothing but, then O2 minus. Very good. O2 minus means it is superoxide. But if you try to remember with only with the anions, you won't remember. Therefore, remember this best example with potassium. So see the potassium and remember the anions. So K2O, K2O2 and KO2. Very easy to remember. Okay. So Haritagala reply, who can go up to superoxide? Unmute and reply, Putha.
Potassium, rubidium, and cesium.
Well done. Potassium, rubidium and cesium. Zainab, are you there?
Yes, sir.
Okay. Right. Okay. So what is the maximum amount lithium can go with oxygen?
Lithium oxide.
Only up to lithium oxide. Well done. Then sodium can go maximum up to?
Sodium peroxide.
Sodium peroxide. Very good. Then who can go up to superoxides?
Potassium, cesium, and rubidium.
Potassium, rubidium and cesium. Then we'll come for the second group. Okay, group 2. Group 2 you can see here. Right, group 2 people you can see this. Right, group 2 people you can see this. You can see beryllium, magnesium, calcium, strontium, everyone, beryllium and oxygen, they will react together. Then normally beryllium and oxygen, they will react only up to certain time and they will form the beryllium oxide. Again, they will react unto a certain time. Okay. Only up to little bit time they will react, they can react because oxide layer will come, therefore they can react up to only little bit time. But magnesium, calcium, strontium, these people can react with oxygen. But barium, only in group 2, barium can go up to superoxide level. What is superoxide now? Sorry. Barium can go to peroxide level. O2 2 minus no? This O2 2 minus. Then how will you write this barium peroxide? How will you write this? You don't write Ba2O2. How will you write for barium peroxide? You know barium is this. Peroxide, you know O2 2 minus. This peroxide. So O2 2 minus means valence is 2. Barium also valence is 2. Then what will happen? This 2 and this 2 get cancelled and you get barium peroxide here. Okay, that is only BaO2. So group 2 people, in group 2, only barium can go up to a peroxide level. So no one can go to superoxide. So in the entire elements, in the entire periodic table, only potassium, rubidium, cesium can go to superoxide level. Other people, they can't go to superoxide level. Right? In group 2 people, everyone go to oxide level with oxygen except barium. Barium can go to superoxide level. Because you have to heat every thing to go for this. But group 1 people, no need to heat. Just they will react with oxygen because they love oxygen. Right? But group 2, you have to chuttak heat it. Then only they will react with oxygen. Right? Is it clear, people? No? Everyone? How they react with oxygen?
Yes, sir.
Right. So now you got a task. Right? The task is, okay, you write S block here in your tube. Write as S block. Right? Under that, write reaction with oxygen here, write it and write all the reactions, whatever you have learned now. Now itself we have to practice, Puta. Please write it. Come on. Now itself do this. Don't be lazy. Now itself do this. How 28 people, can you understand what is happening here?
Yes, sir.
Can?
Yeah.
Yeah, good.
If the
Nice.
topic is S block,
I can't hear you. What?
if the topic is S block, that right?
Topic, S block elements. Reaction with oxygen. Under reaction with oxygen, Taggala write the reactions alone. Come on, we can do this. Once you're done with the reaction, say done, na? And I will ask you to share what you have done now.
So, would I want to write that group 1 and the elements like that?
Yeah. You're right. Like that.
Okay, thank you.
Done.
Done. Well done. Everyone done with how oxide works? Yes? Or still writing? Right. So that is done. Now check whether
Thank
is it correct. Can zoom necessary things. Check, is it correct? Correct? But if you don't practice now, it will be difficult to you later. Done? Correct?
Correct.
I can't hear. Correct? No?
Correct. Correct.
Okay, nice. Now we'll go to the other one. Now you know how they react with oxygen. Now nice. But now we'll say, now after that what we do, we react with oxygen and we put the product whatever reacted with oxygen to water. But when you put to water, remember, if it oxide, it will give hydroxide. If it a peroxide, it will give hydroxide and peroxide. It will give hydroxide and hydrogen peroxide. Likewise, okay, M2O mean oxide. Oxide with water, it give only the hydroxide. And if it a peroxide, like for an example, if it is sodium peroxide and water, it will give sodium hydroxide and H2O2. But if it is superoxide, the superoxide will see, again now, when it oxide, they will try to release only hydroxide, like lithium hydroxide. Now, sodium oxide will give sodium hydroxide, but sodium peroxide will give sodium hydroxide and H2O2. Again, a sodium peroxide will try to do something better than sodium oxide, because sodium peroxide is thinking, I'm better than sodium oxide. Okay, so I'm product loku. So I have to do something else. Okay, sodium oxide itself giving sodium hydroxide mean I should be able to at least release something more than them. So what are they doing? They are reacting with water and they are giving sodium hydroxide and hydrogen peroxide both. Now rubidium oxide is the same thing, rubidium hydroxide, rubidium peroxide giving rubidium hydroxide and hydrogen peroxide. But same way, Buddha, what happens? Right? Rubidium superoxide is the RbO2, rubidium superoxide. Rubidium superoxide will react with water. Now, rubidium superoxide is the like superiorest out of everyone. Therefore, rubidium superoxide is thinking, then I should release more things than others can. Therefore, what are they doing? They will release hydroxide as oxides. They will release hydrogen peroxide as peroxides. Plus, they will release O2 because to show them they are superior. But can you understand what's happening when these people have put into water?
Can you explain again, sir?
Okay, no?
Yes, sir.
Yes,
Can
good.
you explain again, sir? I understand.
I can't hear, some voice is there, but I can't hear that. Not clear, right?
Can you
Therefore,
explain again?
what is the final output? Therefore, all the oxide with water give the hydroxides. All the peroxides will give the hydroxide and the hydrogen peroxide, H2O2. All the superoxides will give you hydroxide, hydrogen peroxide, and oxygen. Okay, same thing here, magnesium oxide and water become magnesium hydroxide, calcium oxide and water become calcium hydroxide, strontium oxide and water become strontium hydroxide, barium oxide and water become barium hydroxide. Here barium peroxide with water, barium hydroxide and H2O2. Why you have put here OH twice here? Because magnesium valence is 2, OH valence is 1. There, you should know that. Right. Clear? Right. Okay, nice.
Sir, is it the same for the potassium also?
Same for the potassium also. Here sodium, rubidium, cesium only given. Same thing for potassium as well. Okay. If you put potassium also here, what you have to do, you have to write the same thing here. Understood now? Right.
Yes, sir.
Now what you want to do is, hurry. Wait. Yeah. Right. Now we'll give you a chance. Now what you want to do is you have to write the left side, and you can see the left side now. Using the left side, write the right side. Can do no? Can do, right? Using the left side, can write the right side. Tell yes, but
Yes, sir.
yeah. Very good. Hi, Tagala right now. If you don't practice now, why we don't have another time? Make it fast, because mostly students say inorganic is difficult. So many things to remember, but In this way, you can remember everything neatly. So you should be able to write a superoxide properly, oxide properly, and a peroxide properly, everything. Make it fast. Uttara, they're done after completing this part. So if you're done, tell done now.
Done.
Done. Well done. Okay. Check your answers. Right. Others? Okay, corrected.
Yes, sir.
So all correct.
Yes, sir.
Well done. Right. Now let's go for nitrogen. Because you should know these valencies. And nitrogen, what is the nitrogen's valency? 3. Right. Lithium's valency is 2. Now carefully see this. But normally lithium is chuttak pandita fellow. Right. Normally lithium is chuttak pandita fellow. Why lithium is pandita fellow? Because lithium trying to imitate magnesium. Actually, lithium trying to imitate magnesium. Okay, because when you take the periodic table, lithium is here. When you take the periodic table, lithium is here. Okay. Magnesium is here. Okay, here lithium, here sodium, here beryllium, here magnesium. So what lithium, again lithium, he loved the person who is with him diagonal. So they have a diagonal connection. So lithium, they try to imitate magnesium. Whatever magnesium does, lithium also trying to do. Lithium now group 1 person, he's belong to actually different family. Magnesium belong to different family. But what these people do is, right, they are trying to imitate, right, they are trying to imitate the same person. Okay. Again, lithium is trying to imitate the magnesium. Therefore, lithium and nitrogen, normally other group 1 people, when nitrogen comes, normally nitrogen is a person, like we call nitrogen as an inert gas. Actually, nitrogen and between nitrogen and nitrogen, they got triple bonds. And nitrogen, like, they are very reluctant to act with another person, right? They got triple bonds and very hard to break these bonds, and really they react with each other. But now normally everyone will say, can't here. Group 1 those people say they don't want to react with nitrogen. So they say, no, we can't react with you. Like, we have a policy, we can't react with you. But lithium is a Pandita fellow. No? So that Pandita fellow, what will do? Right? It will react with nitrogen. It will react with nitrogen, it will form lithium nitride. So how you write lithium nitride? Lithium's valency is 1. Nitrogen's valency is 3. So you have to cross this. And you have to write as lithium nitride like this. You have to write as lithium nitride. Li3 and you should write it. Okay, so this is only lithium nitride. Okay, so again, they don't like it, but still they have to work. Lithium is reacting with nitrogen. Although group 1 people don't like this. And group 2 people, normally they will react with nitrogen and they will form the nitrides. Normally all the nitrides what made by group 2 is white color. Make a white color precipitate. Okay, white color precipitate means the powder will be a white color powder. But lithium, because it done a mistake, lithium did a mistake, because when entire group 1 is telling can't, lithium reacted with nitrogen. Therefore, God got angry with lithium, right? And God gave a curse for lithium, you should blood vomit kill. Therefore, lithium vomited blood, therefore lithium nitride became red color. Do you understand the punishment of the God for lithium? Do you understand that? Tell yes or no? Yeah. Because of the punishment, only lithium nitride became. Because of the punishment, it became red color. All the other nitrides are white. Okay. Now can understand what's happening with nitrogen. Alright. Normally group 1 people telling I can't react with you. But only lithium reacted because of the Pandita Kama. Then because of that, lithium nitride became red. Other nitrides, group 2 nitrides became white. Now, we have a pattern. Whatever after reaction, what we do, we put them to shower. We put them to water. Now we put the oxides, peroxides and the superoxides to water. Then we got the products. Now we are going to put the nitrides to water. But then when you put the nitrides to water, what will happen? Normally lithium and this OH group of the water will join together and it produces lithium hydroxide and it will produce ammonia. Because this nitrogen and this hydrogen, whatever the hydrogen remaining in the water, those things will join together and will produce ammonia. Ammonia is actually a very bad smell gas. Now only lithium understood. Ade, why our people didn't react with nitrogen? Because when we put to shower, it produces a bad gas. Harin gandai, right? Ammonia is gandai, right? They make a very bad odor gas. Hariso ammonia. Then magnesium nitride with water, it produces magnesium hydroxide and ammonia. Calcium nitride with water, calcium hydroxide ammonia. Strontium nitride with water, strontium hydroxide ammonia. Barium nitride with water, barium hydroxide ammonia. It means all the nitrides, when they react with water, it produces ammonia and the hydroxide. Now, Putta, is it clear now? How they react? Did you understand now how they react with nitrides?
Sir,
How
what
they
about beryllium, sir?
beryllium also same thing. You can have whoever make the nitrides, all are same. Same way they will react with water. Clear?
Yes, sir.
Nice. Okay, well done. Right. Now, okay. Now, Putta, what you want to do is, right? You can write these things now. You can write these things mean, wait, I'll cover the other stuffs. Then you can write this again. Now itself practice this, Putta, right? Now itself practice this. I don't keep another time, another date. Don't keep anything like that. Now itself write the left side and complete the right side. Satas gonna do that part. Okay, when you're leaving today, you should know everything. All these reactions to write it alone. Okay. Right, make it fast. Okay, people, done?
Yes, sir.
Good. Now, right. Now check your answers. The answers are correct. Correct? And even put the colors, right? Put the correct the answers. Imla, Zainab, Aniha.
Yes, sir.
Aniha, can you hear us?
Yes, sir.
Okay, good. Now, these things are fine. Now, you know about nitrogen also done. Now, let's see about hydrogen. Putana, now, normally everywhere beryllium reacted with everyone. So far, we reacted with oxygen with nitrogen, beryllium reacted. But when it comes to hydrogen, Putana, these beryllium won't react with hydrogen because normally beryllium is a lazy person to react. Right? Normal beryllium, they don't react with hydrogen. Therefore, you should know beryllium don't react with hydrogen. You should know. And other people, when they react with hydrogen, they make the hydrides. So lithium also valency 1, hydrogen also valency 1. So the LiH is the formula. Beryllium, magnesium valency 2, hydrogen valency 1. So they make MgH2. So these are different. Right? So this is how group 1, group 2 people react with hydrogen. And when you take these hydrides and when you put water, normally other pattern is we put water. What they do, they produce the hydroxide and the hydrogen. Whenever you put a metal with someone with water, they produce the hydroxide and the here hydride, therefore they produce hydrogen. Same thing will happen for group 2 also, HL. Right? So here beryllium hydride maker not reacting now. In some maker should will get side. Here go back inside. Now okay. There was something in the snow. Right? It's supposed to be beryllium oxide. Huh? Here beryllium oxide, beryllium hydroxide and beryllium oxide are amphoteric. Hydroxide and beryllium oxide is amphoteric. Amphoteric means it can act as acid and base both, right? Okay. The rest are basic hydroxides. Right. Good. Hydroxides and oxides. Okay, anyways. Now, but can you remember about how they react with hydrogen? Clear? Speak, will you people? Okay. Now, try this. Everyone write everything. Please write everything and write this because you want to write this, then only you'll get practice. Although these things are written, write this because then only you can get a practice. Okay. Okay. Is it clear?
Yes, sir.
People? Okay. Now check your answers. Slowly we'll go in this, right? Again, when you are leaving today, you should be able to write every single reactions. Even these things also should, now you have to balance this reaction actually. Now, first of all, we are not giving the priority for balancing. Yeah, balancing we'll see later. The first priority we'll see to write this. Okay. Now see water. When you put with water, lithium and water will be lithium hydroxide and hydrogen, sodium and water becomes sodium hydroxide and hydrogen. Any metal with water, it produces hydroxide and hydrogen. Group 1, all the metals will react with water. All the metals will react with water and produces hydroxide and the hydrogen. Right? But the problem is group 2 people. Normally group 2 people, beryllium, normally they don't want to react with cold water. Even they don't want to react with hot water because beryllium is a lazy person. Because beryllium didn't react with hydrogen. So beryllium doesn't react with water also. So it's a lazy person, so it doesn't react with cold water or hot water. It reacts only with the steam. Steam means a gas, no? Therefore, beryllium oxide and hydrogen. But magnesium is a person. When magnesium reacts with gas, it will produce magnesium oxide and hydrogen. But normally magnesium is a person who reacts with liquid, right? So I'll write this here. Stuck. Here the thing is not there. Okay. This I'll change as magnesium. Magnesium react with water, you get the magnesium hydroxide and hydrogen. Again, magnesium will react with this one. This H2O is a liquid, right? H2O is a liquid. But we'll put hot here. I'll write this as hot. Okay, hot water, so it produces magnesium hydroxide and hydrogen. So calcium and water, normally, even in normal water, these people will react. Calcium, strontium, barium can react with normal water. But magnesium will react only with hot water. Again, in cold water, you can't see a reaction. So, especially about group 2 people only, when they are reacting with Chuktak, you have to consider that beryllium can react only with steam. That's the first point. Magnesium can only react with hot water. But calcium, strontium, barium, they can react with even normal water. So, did you understand how they react with water, how these metals react with water? Is it clear? Someone reply?
Yes, sir.
Yeah, well done. Now, normally, when the group 1 people are reacting with water, you can see lithium will react slowly. Sodium will react vigorously. Potassium will react vigorously with ignition. Rubidium and cesium will react with explosion. Okay, again there will be explosion. Okay, potassium vigorously with ignition. When you are putting potassium to water, you will see a fire. Right. So what you have to do now? Okay, now you know to write. No? I don't want to show the screen. You just write. Okay, you just write. Okay. So this is why I have mentioned beryllium don't react with cold water, hot water, no. Steam, yes. Magnesium not with cold water, hot water and steam, yes. Calcium and barium, cold water, hot water, steam. If someone can react with cold water, they can react with anyone. Okay. So understood, Pudha? Now, if you don't keep on writing about the water, now you itself write. Like you write lithium plus water, sodium plus water. Likewise, you write for every element. So give me a minute. Now, these people take a small break now 4:15. Then we'll meet again 4:40, like 25 minutes break. Go and come. Okay. Done with those things, no? Speak, Putha. Hello. Hello, can you hear me?
Done, sir.
Okay, good. Now, first of all, now take a break and come. Okay. Okay, right? Look, I'm sorry. Is everyone are there? Please raise your hands if you're there. Please put your hands up if you're there. Others? What about others? Others, please raise your hand. People, hello, raise your hand. Right, because if you don't go with the flow, it will be difficult to you. Now you know you understood everything, right? Okay. Now I will ask questions from this. Tagala reply. Will beryllium react with hydrogen? Tagala reply. Unmute and reply. Will
No.
beryllium react with
No,
hydrogen?
sir.
Answer is no. Very good. Okay. Will beryllium react with cold water?
No. No.
No. Very good. Will beryllium react with hot water?
No, sir. Yes.
No.
No. Answer is no. Beryllium won't react with hot water. Will beryllium react with steam?
Yes.
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 Okay. Beryllium oxide means what type of oxide is it? Is the acidic oxide,
Amphoteric.
basic oxide, or amphoteric? What type of oxide?
Amphoteric.
Amphoteric oxide. Well done. So you know everything related to this. Will sodium react with nitrogen?
No.
No, very good. Will lithium react with nitrogen?
Yes.
Yes. What is the lithium nitride's color?
Red. Red color.
Red.
Red color. Well done. Okay, nice. This Saturthika, where is Akshaya?
I don't know, sir. She left from the
Man,
school. Or she left from the school. She's doing private now.
is it? Should I
Yeah.
meet her?
You know, I won't.
Okay. Now here they're talking about people, how they react with chlorine, right? So here, okay, beryllium and chlorine, here everything we are taking as reacting only, right? Reaction with chlorine is not a big deal, just you take as everyone will react with chlorine, you just take it. Like all the elements will react with chlorine and it produces chloride. Nothing special with the chlorine. Okay. Okay. All are white color. Okay. Now beryllium react with chlorine only under special condition, but still beryllium can react. Okay. Now all are white. No need much about the chlorine. Just what you have to remember is you should know all people can react with chlorine. That's it. Next thing. Chlorides with water. After making the chlorides, the next step is we put them to water. No, when we put them to water, what will happen? They produce the hydroxide and HC. Lithium chloride, lithium hydroxide, HC. Beryllium chloride with water, we get beryllium hydroxide and HC. Supposed to be. Okay. Beryllium normally won't react with water, but beryllium chloride can react with. Okay. So everyone who are making chloride, they will react with water and they will give you this one. Okay, that part is clear. So there is nothing much related to chlorine. Now normally when we come for bases, right? Remember now out of these metals, normally Metals mean those are basic oxides. Therefore, normally metal base, they don't react. So metal plus base, no reaction. But only amphoteric metals react with bases. What are the amphoteric metals we know? Beryllium, aluminium, zinc, tin, lead. These are the amphoteric metals we will find. So beryllium, aluminium, zinc, tin, lead, they can react with bases. Now beryllium can react with a base while having water. With water, they will form a substance called, this is the substance. They will form actually a complex ion. Now the first time you are meeting a complex ion in your life, right? You haven't met complex ions before, right? So they will form a complex ion, right? They will form a complex ion. This complex ion, this is a complex ion here. That complex ion, this is the way how we write. BeOH4, BeOH4. How you say this? Normally hydroxide. When you take hydroxide, you write as OH minus. Normally when you take hydroxide, you write as OH minus. You know oxidation numbers, no? So one OH minus is -1, then 4OH minus means -4. So in this beryllium, you know, it's a second group person, so it is +2. Then +2 and -4, what is the final answer? -2, no, then this ion will be a 2- ion. So this ion's name is berylate ion. This ion's name is berylate ion. Okay. Now see this thing for aluminium. See these things for aluminium. Now aluminium, you can see AlOH4. So here Al is there. Here OH is there. And 4 is there. And we can put a minus here. AlOH4 minus. Right? AlOH4 minus. No. Now if it AlOH4 minus, I'm sorry. It's AlOH4 කියලා ගත්තොත් what is this? This hydroxide in one hydroxide is -1, 4 hydroxide is -1 aluminium is aluminium, you know, is +3 metal. So we can put +3 here, -4, +3 and -4 become -1. So this is the aluminate ion. AlOH4 minus is the aluminate ion. When you take zinc, zinc is +2. Then this one OH is -4. So when you take the zincate ion, it is ZnOH4 2-. So can you understand how you get these things clear? How you get minus here, how you get 2- here? Okay, everything there is a logic. Clear, Puta? Everyone.
Yes.
Right? So there is a logic behind that. So using that all you can get now this ion when it join with sodium. Now this is berylate ion. Now when it join with sodium, Puta, you can write like this. Now sodium is here. Berylate ion is BeOH4. This is a berylate ion. BeOH4, this is a berylate ion. BeOH4, this is the berylate ion. Normally you put, to mention it complex, you have to put a box like this. And for sodium, you can write it's 1. For berylate, you can write it 2. So finally, you can write sodium berylate as Na2 BeOH. Then you can. So that's why you have written it like this. Can you understand how you have write sodium berylate, sodium aluminate, sodium zincate? So normally when you put this, it will reduce hydrogen. So these are the reactions you can know. Beryllium with sodium hydroxide, it will produce sodium berylate. Aluminium with sodium hydroxide, it will produce sodium aluminate. Zinc with sodium hydroxide and what? It will produce sodium zincate. So did you understand only now out of these things, but only S block element is beryllium. So for I have write only beryllium here, but we wrote aluminium and zinc to understand this process. Everyone clear?
Yes, sir.
So can you write this alone? People? Okay. Now what you do? Write this alone. Write this entire thing. Okay. Write this entire thing. Write this entire thing. I will cover it. Beryllium, aluminium, and zinc with sodium hydroxide. Okay, everything OH4. You just keep in your mind. Okay. Give a try. Everyone. So when you are done, tell done. Imla, are you there?
Yes, sir.
Hello.
Should write the chlorines one also.
No, no need to write chlorine. Just write only the sodium, the zinc, and aluminium, how they react with sodium hydroxide. Okay, you can get the recording, no problem. Okay, people done?
Yes, sir.
Sorry.
Yeah, sir.
Sure. Good. Now, normally metal, they react with acids. All the metal, they will react with acids. Normally, Buddha, remember, all the metal, they can react, right, with these acids. Okay, now lithium, when they react with this one, they will produce lithium chloride and hydrogen. So all the metals, what they produce is their chlorides. When they produce, they produce their salt and the hydrogen. For an example, lithium with HCl means lithium chloride hydrogen. Lithium with HNO3 means lithium nitrate and hydrogen. Right? Lithium with H2SO4 means lithium sulfate and hydrogen. Right? Group 2 also same thing. Beryllium with HCl, beryllium chloride and hydrogen. Right? Beryllium with nitrate, beryllium nitrate plus hydrogen. Beryllium with H2SO4, beryllium sulfate plus hydrogen. So did you understand? So very easy to write the salt and the hydrogen. Whatever the salt behind the hydrogen, that salt and the hydrogen will be released. Clear? Is it clear?
Yes, sir.
Right. And normally we don't react what group 1 element with strong, again, concentrated acids. Now, group 1 people, if you try to react with concentrated acids, what will happen? Normally, concentrated HNO3 and concentrated H2SO4, we don't react group 1 element because it will cause a massive explosion. Right? It will cause a massive explosion. Right? Therefore, only group 2 people will react with this concentrated HNO3 and concentrated H2SO4. Right? Only this diluted and concentrated are different only in this what? Only in H2SO4 and HNO3. Remember, we are considering only that concentrated diluted in this part. So, in the concentrated part, okay, you get magnesium sulfate, SO2 and water. Here, calcium sulfate, SO2 and water. Strontium sulfate, SO2 and water. Barium sulfate, SO2 and water. Okay, you get the SO2 and water when you react with concentrated one. When you try to react with the concentrated HNO3, you get the nitrate NO2 and water. Okay, NO2 is a gas, where is a brown color gas, right? Normally NO2 is a brown color gas. SO2 doesn't have a color, but what happens is like it will give you like some pungent odor. Okay. A group 1 element does not react with the concentrated acid If it reacts with concentrated acids, it will cause explosion. Okay. If group 1 elements react, okay, group 1 element does react with concentrated acids with, okay, with explosive nature. Okay, therefore we don't write. Okay, so can you understand now? Now I am giving you a time. What you have to write is, you have to write, okay, for these things. Group 1 element, group 2 elements, you have to write with DIL HCl. So DIL HCl means HCl, DIL H2SO4, DIL HNO3. Then again, group 1 and 2 elements, you have to write with concentrated HNO3, concentrated H2SO4. Give a try. Again, you can see you get the salt, SO2 and water here. If you put the concentrated one. If you put the diluted one, you got this salt and hydrogen. That's it. Here you are getting SO2 and water, not hydrogen. And ඒක මාර විදියට remember හරි. Give a try පුතා. Can try no people.
HCl
HCl, DIL H2SO4, DIL HNO3, concentrated H2SO4 and concentrated HNO3. Give a try. Done, Puta?
No, sir.
Be well done. Done, Putha, done. Okay. Hello. Can you reply? Satrutika done.
No,
Raymond,
sir. Two
Imna,
more.
Aniha. People done? Hello?
Yeah,
Shall I done?
sir. Done.
Yes, sir.
Now you can see all the acids will produce their salt and hydrogen in dill condition. HCl, we don't have a dill conc condition. Dill and conc both acting as same, right? But HNO3 and H2SO, what will happen? HNO3 will give you the salt, NO2 and water. H2SO4 will give you salt, SO2 and water. You wrote like that? Okay. Right. Okay. Now see this with the carbon dioxide reaction. Okay. This one is not that important for you, how they react with carbon dioxide, right? It actually not necessary much. Okay, just ignore that carbon dioxide part. Okay. But if you want, right, you can see all the hydroxide when you put with carbon dioxide, it will give you bicarbonate. So those carbonate, when you treat with excess carbonate, now we'll say sodium, you're getting sodium carbonate. Those sodium carbonate, if you react with excess carbon dioxide with water, it will go up to sodium bicarbonate. Okay, so it will happen like that. I think this reaction is less important to remember, Elisa. You can ignore that at the moment. Now we can go for the stability of the bicarbonates. Now, Buddha, remember, now group 1 and group 2 bicarbonates when you take, group 1 are stable only in the aqueous condition. Only in the aqueous condition, group 1 is stable in both aqueous and solid condition. But when you take the group 2 people, right, those people are stable only in aqueous condition. You have to remember that. Okay, but group 2 are unstable in solid condition. For an example, if I say magnesium bicarbonate, so magnesium bicarbonate means group 1 or group 2? Yeah. Children, please speak. Magnesium bicarbonate means group 1 or group 2?
Group 2.
Group 2. And they are stable in which condition? Aqueous or solid?
Aqueous.
Very good. Aqueous. Group 2 are only stable in aqueous. They are not stable in solid. So you have to remember that. Right. So we have to see the now decomposition. Decomposition means when you are heating, what will happen? But normally remember, all group 1 except lithium. I said lithium is acting like group 2. No, that's why they have written except lithium. So all group 1 people, all the group 1 hydroxides, when you heat it, no reaction. When all the group 1 carbonates, when you heat it, no reactions. By bicarbonate, if you heat it, it gives you the carbonate, carbon dioxide and water. If you heat the nitrates, nitrate means NO3. For an example, nitrate, I'll write and show you an example for nitrate. We'll think lithium nitrate. For an example, we'll think lithium nitrate. So when you take lithium nitrate, okay, when you take lithium nitrate, what will happen? Now lithium nitrate, this one, okay, lithium nitrate. When you take the lithium nitrate, now we'll think you are heating this. So it will give you lithium nitrite and O2. Lithium nitrite means LiNO2. Okay, nitrite. These only nitrite. NO2 only nitrite. If you don't know, you can write it. NO2 minus is nitrite. NO3 minus is known as nitrate. Okay, NO3 minus is known as nitrate. Right? And that's why nitrite mean NO2 minus, nitrate mean NO3 minus. Okay. Carbonate mean CO3 2 minus. Carbonate mean CO3 2 minus. That is only carbonate. Bicarbonates mean HCO3 minus. Bicarbonate mean you get a hydrogen. Okay, HCO3 minus is only bicarbonate. Okay, hydroxide mean OH minus. You can write this. Hydroxide mean OH minus. Okay, but how group 2 people with lithium? A group 2 and lithium acting at the same way. In the hydroxide, will give the oxide and water. Carbonate will give the oxide and carbon dioxide. Bicarbonate will give the carbonate, carbon dioxide and water. Nitrate will give oxide, NO2 and O2. So this is how they will react. Now let's see. So you can see how they are reacting. This is hydroxide. When you heat the hydroxide, you can see no reactions. But when you heat the group 1 carbonates, no reaction. When you heat the group 1 bicarbonates, you can see it will produce sodium carbonate, CO2 and water. Right? Then nitrates, it will produce NO2 and O2. I said no, sodium nitrite, O2, potassium nitrite, O2. Group 1s will give you the nitrite and O2. So understood how they react with these hydroxide carbonates, bicarbonate and nitrates?
Yes, sir.
Right. So can you write it? Decomposition kela, you just write decomposition.
Yes.
Under decomposition, you can write these things. You can put a heating mark under this. You know how to put a triangle under each arrow. So it shows you heating. Okay, you are heating this. Huh? When you heat these things, what happens? Only decomposition. Tagala, try to write this. Right, done? People
Yes,
done?
sir.
Good. Now check whether it's correct. Now we practice so many this one. Can you remember everything what you learned today, Putha? Yes or no? Can remember everything, right? Hello. Tell me. Can you remember everything what you learned? Hello. Yeah. Tell. Satutika, Zainab, Bimla, Ania. Can you remember everything whatever you have learned today? Yeah. Yes. No. Tell something. I can't. I didn't hear you. Yeah. Can you remember? Putha, please someone tell. Can you remember everything? Yeah. Right. Putha, can't you remember everything what we have studied from the beginning? Takala, come on. Tell Imla, can you remember everything what we studied? Zainab, can you remember? I can't hear you, people. Are you speaking? You can just unmute and keep your microphone for some time and speak. Speak, will you? Hello?
Can that
Can, good. Nice. Now say this, the next one. Now group two people. When you are heating, what happened? I said group two people only will, group two hydroxide and group two carbonates can break into oxide and hydroxide and oxide and water. Carbonate now become oxide and carbon dioxide. So the bicarbonate mean it will go to carbonate, carbon dioxide and water as same as group one. Group one was the same thing. No? Carbonate, carbon dioxide, water. Right? And the nitrates. What happened for nitrates here? It's completely different. Right? Brown smelly gas brown gas. Right? It's a brown gas. Right? No, it's a brown gas. Now this one, see nitrates, what will happen? Nitrates earlier, sodium nitrate, what happened? Sodium nitrite and what we got? Speak, will you? I can't hear you. Sodium nitrite and oxygen. Here what happens? You get the oxide, NO2 and O2. In the this one, in the group one, we didn't get the NO2 here. You can see in group one, we didn't get NO2. Okay, we just got the O2. But in group 2, what we get? We get the NO2 and O2 both. We get two gases in nitrates. So can understand now? Okay. Right. So now what you have to do? When you make it, try to write. How when you heat, what will happen? Okay. When you heat the hydroxide, what will happen? When you heat the carbonate, what will happen? When you heat the bicarbonates, what will happen? Can these all are same pattern? Hari, pattern is same. So you can at least understand and write this. Okay, come on. Okay, done? Okay. Someone please reply with it. Yes?
No,
Sorry?
sir.
Okay. Because the more you write, the more you get the practice. Huh? Right? Okay.
Yes, sir.
Okay. Good. Now, next. Now write for nitrates. Write for nitrates what happens when you heat nitrates, group 2 nitrates. Done? Okay. That. Now, very good. Now you have a knowledge on everything related to this one. After that, finally, we'll summarize this thing. Right now, we'll see about halogens. So when you take the halogens, you got several type of halogens like NaOCl, NaClO2, NaClO3, and NaClO4. Remember, all these halogens, when you heat, it becomes just chloride and oxygen. That's it. Okay. So same thing will happen for other halogens also, like bromine, iodine. If you put Br here, same thing will, all the Cl will replace by the Br. If you put iodine here, all the iodine will replace by I. Yeah.
So what are halogens?
Halogens mean group 7 people. Group 7 people, like fluorine, chlorine, bromine, iodine are known as halogens. Okay. Okay.
Okay, sir.
So here the toxic gas is carbon monoxide. Here the toxic gas is carbon monoxide. Right? So carbon monoxide is a toxic gas. So that is calcium oxalate. Calcium oxalate means CaC2O4. When you heat it, you get calcium oxide, carbon dioxide, and carbon monoxide. Okay. Right. So this is the calcium oxalate decomposition. These are less important. These two are less important stuffs, right? Just to know. So finally with ammonia. Okay. Normally group 1 people with ammonia, they will make a thing called amide. NH2 mean the name is amide. Okay, lithium amide. Actually, this is NH2 minus. So LiNH2, NaNH2, KNH2. These are as lithium amide, sodium amide, potassium amide, rubidium amide, cesium amide, and hydrogen. So normally if ammonia react with group 1 people, it releases the amide and the hydrogen. But if group 2 people react with ammonia, I mean, it will cause the nitrite and hydrogen. Very important. Okay, so earlier you can remember like these people, when it react with nitrogen, it made nitrite. Likewise, when it reacting with ammonia, group 2 people when reacting with ammonia also, it will produce nitrites. Mean make an important. Can understand this, sir? Okay. So get
Yes,
ready
sir.
on this. I will have an exam on next Wednesday based on this. Right? Next Wednesday, I will have an exam. Yeah. Please write this.
Sir, then that unit 4 and unit 5 exam.
Separately there, I will have a small exam on this. Unit 4, 5 exam also there. That is, however, 1.5 an hour exam. We have to recall it, whatever we have learned. Right? Okay. Okay, done?
Yes, sir.
Okay. Check. Correct. Now next thing. Okay. So finally we have to come to the solubility of this thing. Right. So this solubility, I will speak. Normally, all the group one element are soluble. Okay, all the group one sodium, potassium, rubidium, cesium. The potassium is missing here. Can include sodium, potassium, right? Rubidium, cesium. Potassium, rubidium, and cesium. All these elements are soluble in water. That is only solubility. Right? All these elements are soluble in water. Right? All these elements are soluble in water. Now, normally lithiums are insoluble. Now, when you take the salts, nitrate, NO2 minus, acetate, bicarbonate, dichromate, ammonium plus, these salts are soluble. Group 1 halides are soluble. Halides mean, you know, like sodium, chloride. Halides, we can put except fluoride. Except F. Except fluorides. Except fluorides. It's not right. Except fluorides. I don't know. Is it working?
What's halides?
Huh?
What's halides?
Halogens mean group 7 people. Halides mean group 7 people's anions. F minus is halide. Cl minus is halide. Br minus is halide. Okay.
Okay.
What's happening? Right. Anyhow. Now, this one except fluorides. Except fluorides, other halides are soluble. So, sodium chloride is soluble. Sodium bromide is soluble. Sodium iodide is soluble. But sodium fluoride is not soluble. Fluorides are not soluble. Other one, group 1 sulfides, carbonate, phosphate, sulfate, everyone are soluble. Now, when you take group 1 people, all are soluble people. Right? Group 1 elements, all are soluble. Okay, but in group 1, lithium is not soluble. When you take group 2, all, remember, if you have nitrates, nitrite, acetate, bicarbonate, dichromate, ammonium, you can have all these ions, whatever here, all these ions are soluble even in this. But group 2 halides are not soluble, and magnesium sulfate is not soluble. Okay. Sorry, magnesium sulfate is soluble. But normally other sulfates, right? Calcium sulfate, strontium sulfate, barium sulfate, these are insoluble. Okay. And sulfide, carbonate, phosphate, sulfite, these are not soluble. Normally in group 1, sulfite, okay, carbonate, phosphate, sulfite, all are soluble, right? But when you take this one, these are insoluble. Okay, so you can remember this chart, so you will get to know about the solubility, right? So these are things you should know today, and I hope you can understand this, right? So I will share the note, so you can study this part. Then you can get prepared for the next session. Okay, so we'll meet in the next session. Bye. So next Wednesday we are having physically. You guys come. Hari, any doubt?
No, sir.
So did you understand